Hello everybody and welcome back to our next PowerPoint in our weather unit. Hello everybody and welcome back to our next PowerPoint in our weather unit. This is a pretty big concept, and it is so big in fact that we're going to do this PowerPoint now in our weather unit, and you will see this weather PowerPoint again in our space unit. And the reason why, it's a pretty abstract concept. It's a hard one to get our heads around, so we'll come back to this a few times throughout the year, but definitely twice for this video. So without further ado, let us to discuss, how does the Earth move? It goes that way. No, actually, our planet is constantly in motion. Every day, our planet makes one full turn on its axis. An axis is an imaginary line that our planet rotates on. Oh, look! It's a bold-faced word down there. You see it? It's I can't point the right way. It's there. Write that down. Okay, here we go. You've caught on by now. Bold-faced underline word means to hit pause and to slide over to our Shobi app, write that word into the worksheet, and then slide back over here to the presentation and then pause again. I know. Quit it, Mr. Eckler. Yes. If we were to draw a line from the North Pole to the South Pole, you can see how our planet would rotate on this line. But there's a problem. We don't exactly rotate this way. No, the Earth, in fact, spins this way. We kind of spin on an axis. We spin on an angle. Our planet is turned on an angle of about 23 degrees off center. Just about 1 o'clock, just slightly after, if you look at it as a clock. Our planet makes one complete rotation on its axis once every 24 hours, or once a day. Coincidence? No, actually, it's not. While our planet is rotating on its axis, it is also moving around the sun. That's right. You see, the path rather, that our planet Earth takes around the sun is called an orbit. An orbit is a circular path that one object takes around another object. Now, it's not just planets around the sun. It could be, moons around a planet. It could be me running around you on the playground. That would be considered to be an orbit. It takes the Earth 365 1/4 days to make one trip around the sun. So, why do we have seasons? Well, as the Earth orbits around the sun, we have our seasons. Now, the question here is, where will we have summer in the northern hemisphere? Will it be here at point B, or will it be there at point A? Raise your hand if you think it's there at point B. Now, who thinks it's there at point A? Well, if you said point A, no, wait a minute, that's not right. It's point B, because point B, we're closer to the sun than we are at point A. Wait a minute, have I made a mistake here? What's gone wrong?
Excuse me, the teacher. The computer is quite correct.
What do you mean? How can it be correct? Who are you?
How close we are to the sun has nothing to do with our seasons.
I think I have a computer virus.
It's the axis or the tilt of the planet that gives us our seasons.
Oh. It is?
Human teacher, please sit down so I can explain.
Okay.
If you were to stand in front of this fire, which were back or front, you have faster.
I'm thinking my front. Front, yeah? What do you think?
What if you turn around? What would happen to your front and back then?
Well, my front would cool off. My back would heat up, wouldn't it?
Exactly. Your back would heat up, and at the same time, your front would cool off.
That's what I said.
But a fire this big, would it matter if you were here or here? Would it still be just as hot?
Well, with that fire that big, I mean, a couple of feet wouldn't make any difference whatsoever.
The Earth sitting in front of a giant flame as well. We call it a sun.
I've seen that thing before, yeah. As the Earth rotates,
the side facing the sun heats up, and the
side facing away cools off. And something's wrong with Hal's voice here.
But of course, the Earth doesn't rotate this way, does it? It rotates on an axis. Notice how the South Pole is constantly facing the fire, and the North Pole is constantly facing away.
That makes sense.
The North Pole will not receive any of the sun's light or heat.
Poor North Pole. It's going to be all dark and cold up there.
By contrast, the South Pole will receive total light and heat all day and night.
So, like, there's not going to be any dark at all at the South Pole. That'd be cool.
The Earth is being heated unevenly. This happens every day of the year. It is the uneven heating of the Earth that gives us our seasons. When one of the Earth's poles faces the sun, it is summer in that hemisphere. When the other pole is pointed away from the sun, it is winter in that hemisphere. Thank you, human teacher. You may teach now, returning control.
Well, thanks so much for letting me teach again. But we did learn something, right? So it doesn't matter that we are here or here in relationship to the sun, because true, we are a little closer at one point in the year during the other point in the year as far as our distance away from the sun. But what is interesting to note, that it is actually the axis of the planet that creates our seasons, not the relative distance between the sun at one point or the other. Now, with the North Pole facing the sun here, this means that the sun is receiving all of the heat. The South Pole is not receiving any heat whatsoever. So this means that this is going to be the summer and this is going to be the winter. And what is most interesting here to note is that the Earth is actually furthest away from the sun during our northern summer. Who knew, right? 6 months later, now, the opposite is true. We have switched positions in the solar system. We are now on the other side. I'm going to go. We are now on the other side of the sun, and now it is summer in the southern hemisphere and winter in the northern hemisphere. Even though the Earth is closest to the sun during the winter, because we are pointed away, the sun stops right here. There is no light reaching the North Pole. So it is dark 24 hours a day for a month. It's cold in the North Pole. That's what I just said. Ha! 2 times a year, the poles receive 24 hours of total light or total darkness. This is called the summer or winter solstice. Hey, write these down. The solstice marks the beginning of either the summer or the winter seasons.
Okay, we know.
We know where the summer and winter are.
We know where the summer.
So which one of these is the spring and the fall? I think Hal has the hiccups. Okay, summer's here, winter's here. Which one of these is spring if it's going this way around? So what comes in between summer and winter? So this must be, the fall. And this one must be the spring, right?
correct. You're pretty smart.
See, we are that good. So yes, fall is in the north here, or in the north, good, at the top, and the spring is down here at the bottom. And we just need to follow the path the planet makes around the sun in order to figure out which season is which. Now, these 2 points in the year mark the beginning of the spring and the fall. These are known as the equinox. On the equinox, the Earth receives 12 hours of day and night at both poles. The spring is called the vernal equinox, and the fall is called the autumnal equinox.
Observe, tiny humans. Look at how the light shifts across the planet over
A course of 1 year. This is actually quite a neat video. This is taken from a satellite that is hovering right over Australia. That's Australia down here. And what this is showing us is the Terminator line. I'll be back. No, not that Terminator. This is the Terminator line between the day and the night side of the planet. And what you are seeing is over the course of 1 year, how that Terminator shifts and how the North Pole and the South Poles are just enveloped in total darkness. Right here, oops, I was just a pinch late. This is almost the equinox. It's just slightly off. And right here, this is the, yes, that's right, this is the winter solstice. This up here, the North Pole, it's not going to get any light whatsoever. Down here at the South Pole, it's the summer solstice. They're going to have 24 hours of light. And this is the spring equinox for the North Pole, the autumnal equinox for the South Pole. And right here, we have the summer equinox for the North Pole and the the summer solstice for the North Pole and the summer solstice for the South Pole. We'll watch it one more lap around. And this was just taken 1 picture a day over the course of 365 days. This is kind of a neat little thing that they did there. That's all we got, folks. Do me a favor, fill in that quiz, and we've gone on long enough here with this video, and we will talk about the quiz next time in class. You all have a great night. Thank you all very much for watching.